Hi, my name is Jessica Van Swoel, and I am the Healthy Watershed Specialist at St. Clair Conservation. Today, we have Annabelle Rayson, a grade 10 student at St. Patrick's Catholic High School in Sarnia. And Annabelle is going to be sharing with us a bit about her science project that she completed on algae bloom prevention and control. Hi, Annabelle, how are you?
I'm good, thank you. And thank you so much again, Jessica, for having me on. So my project is called Munching Madness, an innovative analysis of zooplankton biomanipulation for algae bloom prevention. Algae blooms are harmful large growths of algae that cover the surface of the water and release toxins harmful to humans, plants, and animals. They raise costs and contaminate drinking water. They can release toxins again that can cause severe illness and possibly death in humans. And of course, they destroy water quality and ecosystem diversity by blocking out sunlight, releasing toxins, and causing dead zones. Biomanipulation is when an ecosystem is manipulated to create a desired effect, and zooplankton are teeny tiny little aquatic organisms that are found in all aquatic environments and mainly consume algae. Zooplankton could have their presence increased through biomanipulation in freshwater environments to prevent and treat harmful algae blooms. However, it's unknown which species of zooplankton is best for this purpose. The purpose of my experiment was to test the effectiveness of 4 different species of freshwater zooplankton: Daphnia magna, copepods, Cereodaphnia, and amphipods, independently and in combination with each other on 2 different types of algae, chlorella and solanastrum, in 4 different concentrations: 25%, 50%, 75%, and 100%. My hypothesis was that the Daphnia magna would be the most effective independently, as they are the largest size filter feeder in the experiment. The combinations containing amphipods should be the least effective, as amphipods are omnivores and will likely consume the other species of zooplankton they are combined with first. The combinations containing Daphnia magna, again, should be the most effective due to its larger size. And the solanastrum should be the algae with the most decreases, as it's a microalgae and easier for the filter feeders to consume. For my procedure, I took 264 little plastic cups, and I ensured that each cup had 12 milliliters of liquid with the different algae concentrations, and that each cup, except for my controls, had precisely 6 zooplankton in them. I then let this sit for a 2-week period, and once that was up, using a hemocytometer and my microscope, I counted the algae cells in each of the samples, and then I used Excel spreadsheets to make calculations. I discovered that the Daphnia magna was the most effective species of freshwater zooplankton to biomanipulate, as when tested on chlorella algae, it resulted in an average algae decrease of 89%, and when tested on solanastrum algae, Daphnia magna resulted in average algae decreases of 98%. And by discovering the best species of freshwater zooplankton, Daphnia magna, to biomanipulate to increase its presence to prevent and treat harmful algae blooms, the future of algae bloom treatment and prevention is much clearer.
Wow, that was awesome. I love the diversity in the number of species you chose, the different concentrations that you looked at, and I think a really well thought out, in-depth research project, especially for someone in grade 10. That's phenomenal. So can you tell us how, was this a research project you needed to do for high school or for a bigger science fair? What was this connected to?
So this was something I did independently. For the past, this is my 6th year, I've participated in the Lambton County Science Fair, the local science fair in Sarnia. And my projects have always been on environmental sustainability and living in southwestern Ontario and being surrounded by the Great Lakes and our beautiful freshwater ecosystems. I've always developed a passion for them. And when I learned about harmful algae blooms, I was kind of more interested in looking at the causes of them and ways to prevent and treat them. And so for my project this year, I chose to look at different ways to decrease and prevent harmful algae blooms, and I chose to focus my project on the process of biomanipulation and using zooplankton. And as a matter of fact, I've actually placed best in fair at the Lambton County Science Fair, and I'll be progressing on to Youth Science Canada's Canada-wide Science Fair in May.
That is incredible. And what does that entail?
Well, traditionally it's virtual this year, but it's usually a week-long event at a different host city in Canada, with competing against the 500 best and brightest science fair projects. And so this year, since it's virtual, it's themed in Ottawa, and so we'll have virtual calls with judges, similar to what we're doing today. And we get to create and produce little virtual boards, and there'll also be different virtual tours and events to keep morale high.
Awesome. This is kind of like a little warm-up then for you. That's awesome. Now, who did you work with? It sounds like this is quite a big project. I think earlier you and I were talking about your living room and your kitchen. Can you tell us a bit more about who you worked with and how you set up the project?
So I spent about 6 months researching this concept on my own, and I did my experiment in my living room, my kitchen, and my family's been incredibly supportive and helpful with this. And whenever I've come up with little hiccups or guidance questions, some of my algae and zooplankton were provided to me from Faye Ferguson and his team at Polytech in town, which is a local biology lab. And then I've also worked with Marianne Racine from Environment and Climate Change Canada. She's helped me when I've come up with hiccups on how to calculate and figure out different ways around my project and to expand my research. I've also worked with Curtis Tamming at Lambton College. He's provided me with calculation assistance and lent me the hemocytometer. And Mrs. Diane Yurkowicz, my curling coach and teacher at St. Pat's, she's kindly lent me the microscope. And then, of course, I've worked with you in the St. Clair Conservation Authority when I've come in with questions about the zooplankton.
I feel like we have, I think you've surrounded yourself with some really great researchers and individuals who have been instrumental in getting the project off the ground. It's amazing, and I really think it's great when we can encourage the next generation, especially young women in STEM. And on that topic, where do you see your future after this research project is over and after you're done high school?
Well, after this project, I plan to move on to the next science fair project. I have 2 seasons left before I graduate high school. And after high school, I'm looking into either pursuing a career in STEM or a career as a lawyer.
Wonderful. I'm just trying to think if there is one more. Oh, what made you choose this topic of algae blooms?
Well, again, being surrounded and living in southwestern Ontario, I see the Great Lakes all the time. I love our freshwater ecosystems. I guess environmental sustainability and science has been instilled in me since a young age, so I'm always researching and trying to learn more about the area around me. And when I heard about harmful algae blooms, I found it fascinating since it talks about nutrient pollution and it pulls on ecosystem diversity and ecosystem destruction. And it's really close to me. It's at one of the most impacted lakes, I would say, is Lake Erie. And so I wanted to find out more ways to treat and prevent them from occurring.
Awesome. Well, thank you so much for taking the time to share your research project. I'm going to try, if it's possible, to, when we post this, also post a link to your science fair project. So if people are curious to see more in depth of what you've done and what your results were, they'll be able to see it there. And awesome. All right. Thank you so much. We'll pause it there.